Ready to explore the cutting edge of digital infrastructure? I'm Carrie Charles, your host of Let's Get Digital. Join me as we dive into the ideas, technologies, and leaders transforming the way we connect. From wireless telecom to fiber networks, data centers, and beyond. Sponsored by Broadstaff in partnership with RCR Wireless News. Now, let's dive in and let's get digital. Thanks for joining me today on Let's Get Digital. I am Carrie Charles, your host, and I am so excited to introduce you to this guest and this company. We have had some amazing conversations, and I really think that you are going to want to hear about what Gauri Potdar has to say. So I want to introduce to you Gauri Potdar. She is the CCO of GPC infrastructure. So stick around. Again, you're going to love this. Gauri, let's get started right away. Tell me about you first. I want to know, how did you get to where you are in the seat that you're in, and just a little bit about your background. I just found that so fascinating.
Well, Carrie, first of all, thank you so much for letting me be part of Let's Get Digital. I love the name. It's really wonderful. And thank you so much for taking the time to learn more about GPC, our journey, what we're trying to do. So, yeah, my name is Gauri Potdar. You got that perfectly.
Wait, you say it a lot better than I said it. I'm sorry.
Perfect. It's perfect. And yeah, a little bit about me. You know, this is I'm dating myself now, but I've spent over 20 years of my career in energy and energy commodity markets. Adjacent to that, I am a native Texan. You could say, you won't hear the twang, but I am a vegetarian Texan. Grew up in the DFW area. I spent the last 15 years in Houston. Started my career as a consultant and then moved very quickly into a renewable energy development and environmental trading commodity company, which was a startup at the time over 15 years ago, and did a lot of trading fundamentals, analytics, learned a lot about natural gas and power markets. We were developing renewable energy assets and then trading around those. So got a lot of exposure to natural gas, power, and regulated environmental commodity markets. Moved around to different companies. Platts, I went there. They're a price reporting agency for natural gas, power, a bunch of commodities, and spent a lot of time there looking at emerging markets, and found my way to looking at how water was being reshaped by unconventional shale development, and helped us found a water company, actually, that developed long-term infrastructure to handle oil field water, was private equity backed, very similar trajectory from water not being an issue at all, and then it was the only thing that people cared about, similar to what we're seeing in data centers. Power was in the doldrums for a long time, and now it's the only thing people care about. So co-founded that company, saw it through a very successful phase. We exited through a sale to a private company, and the management team was really founded in upstream oil and gas power, had done a lot of work there, and so reformed, launched again with our capital provider as GPC to kind of bring energy capital and the whole notion of providing energy as a service to the data center through a behind-the-meter on-site natural gas generation model. And so kind of that's where I am here to talk about. That's what GPC does. We provide on-site natural gas power to data centers, specifically and exclusive to data centers. This is all we do. This is our reason to exist as an alternative or a supplement to the grid connect. And our value proposition is to cover that entire value chain from gas supply to operations to commodity risk management, and provide this as an easy button to the data center. So that's a little bit about my journey and what we're trying to do at GPC.
I want to hear all about this. I have a lot of questions for you. First, what has been the most, surprising or maybe unexpected challenge or success in bringing this energy as a service model to data centers?
You know, when we first launched this company and started talking to data center operators and just were in the mix of everything that's happening, the only thing people would ask about, and it would be kind of almost the first question, which is lots of discussions around equipment. What's your turbine strategy? Do you have turbines? Are you using turbines or recips? Like, what's your equipment approach? And really, the thing is, we took a step back and looked at where the constraints were in this market and what needed to happen to deploy natural gas on-site power for data centers successfully. The thing that we realized is it's a whole value chain and not just a single piece of the puzzle, right? I mean, equipment is an important piece. It's really critical. Don't get me wrong. Having access to engines or turbines, having the right facility design, all that's really critical. But when you take a step back, right, and think about, okay, what is it requiring from us to deliver reliable baseload power to the data center? The value chain is super complex. There's a lot of components to it. You're talking about, can you get firm gas supply? Can you manage air permitting? Can you navigate whether you're a non-attainment and attainment? How do you handle that? Can you navigate the local regulatory framework? I mean, we've got deregulated power markets, we've got regulated power markets, you have regional transmission organizations, you have PUCs. How do you structure around that? Do you have access to supply chain? What's the right facility design for an AI deployment, right? How do you design for redundancy and reliability? How do you package all of this under a power purchase agreement? And how do you manage operating risk? And how do you deliver reliability? So when you kind of look at all of those pieces, all those things are important. And so it was surprising to us that while the initial focus is only on the equipment, right, there's a lot of things that have to come together behind the scenes. And so, our approaches, we're partners, we're problem solvers, and really that breadth of that value chain experience we bring coupled with energy strategy, like energy capital, I think has been really resonating with our customers and the conversations that we're having.
When we talked, I think last week, you had mentioned that GPC assumes the operational and commodity risk.
Yeah.
So can you elaborate on what this means for data centers?
It's a really interesting conversation because the key here for us, and I think the key to success for this solution is reliability. You have to be reliable, whether that's 5 nines at the rack level, that 100%, nearly 100%, and 5 nines uptime. That's really, really what we're trying to do, right? And so as an operator and owner of behind the meter on-site generation assets, we take on that operational risk, right? So that means we have to think about redundancy from an equipment perspective, whether it's N+1 or N+2 for a turbine or an engine, uninterrupted gas supply, balance of plant equipment, electrical design, like all those things, part of operational risk. And when we say we take that on, that's in our wheelhouse. We provide service level guarantees to our customers that we can stand behind based on this, and we take all of that on. Commodity risk is a really interesting question, right? Because in order to deliver on-site power, you have to have firm gas. And when you talk about gas, there's really kind of 3 pieces of it. There is getting the gas molecules. You have to have the molecules, the energy to be able to use in the facility. You need firm transportation to get the gas where it needs to go. And a lot of times that's the biggest constraint. And then you're going to have intraday fluctuations. Everyone knows data centers operate, there's ramp ups, there's ramp downs. You're not going to be at a steady utilization level constantly, right? So there's fluctuations, and managing all of that intraday balancing is part of what we call commodity risk management. And then there's a third piece, which is once you have a power asset, you're primarily dedicated and serving the data center, but you have the option to put power on the grid and to solve like grid constraints, right? And there may be pricing benefits to be able to interact with the grid and take power from the grid. So as a generator interconnected to the grid, that's value we can bring in managing that process as well. So that's kind of what we mean by taking on kind of operational risk and commodity risk. That's kind of part of that whole value chain.
So beyond speed to market, control, capital, how do GPC's sustainability options for data centers compare to traditional grid connectivity?
When there's this paradigm shift to on-site power, there's a lot of questions. Okay, you're using a fossil fuel. There's ESG commitments that people have made to try to be carbon neutral, to drive to net zero, to reduce water use. All of these kind of components. I would actually argue that on-site generation gives you a lot of flexibility to handle all of these. And let me give you a really specific example. So if you look at the efficiency of the grid overall, it's kind of in the mid 30s. you've got transmission losses, you've got distribution losses, you've got generation that, fluctuates up and down. So the grids call it about 34-35% efficient. If you have a simple cycle on-site power facility on its standalone basis, you're already a little bit more efficient because you don't have the line losses associated with transmission and distribution. You probably 37-38% efficient. But on-site power gives you the option to capture the waste heat, which is a waste product that normally you wouldn't, this is actually very standard in large industrial complexes, is to capture that waste heat. For the data center use case, you can actually use a technology called absorption chillers to provide a cooling stream to the data center. So you're taking a waste product, providing a cooling stream to the data center. There is CapEx involved, minimal OpEx because you're taking a waste product. But what you're doing for the data center is you're reducing their PUE, you're unlocking additional compute capacity, and on a greenhouse gas emissions intensity basis, you are in many cases up to 40% better than what the grid can offer from an emissions perspective. So doing an on-site project and being able to capture the waste heat inherently, you have a very, very sustainable path to get to an 80-85% efficient solution with a technology. And it gives you options. You don't have to do that right away. You can do that later on. The second is, I've started a renewable natural gas business in a prior life. I've helped to, source those projects, schedule that gas, and provide a mitigation strategy for methane, which is a very potent greenhouse gas. On-site natural gas generation, you can actually source renewable natural gas and blend it into your traditional natural gas stream. And on a near real-time basis, this is very, very carbon intense, like negative carbon intense product. You can offset the emissions that you are generating by using renewable natural gas that's negative carbon intensity. And then there's always options to bundle hourly renewable energy credits or carbon offsets for a full sustainability wrap. So I would say with on-site generation, you have everything that the grid offers, right? The grid offers you the option to sign virtual renewable energy PPAs. You can offset. You have all of those options. Plus you have the option of blending in RNG. Plus you have the option of having a really, really efficient on-site solution by capturing waste heat. So I think you actually expand your option set and not collapse it by bringing the locus of control closer to where the consumption's happening.
So I can hear that GPC is a problem solver, right, for data centers. Can you give me one other, example, but more of a specific use case, a specific time where you went into a client, and you don't have to say the client's name, but take us down that path.
Yeah. Well, I'll give you two examples, okay?
Okay.
One example, we had a customer that had a site. They'd gone down the path of developing that site. They thought they would have utility power. Turns out the utility power couldn't get delivered for 5 or 6 years. So they came to us and said, hey, can you do something with on-site natural gas? We looked at a lot of different options. We looked at, could we get firm gas supply there? Well, it turned out some of the existing pipeline networks that were serving that area were subscribed. There wasn't firm capacity available to where we could get the gas. We looked at, could we do on-site storage and supplement that with pipeline gas? Then we realized through some of our conversations and being in the market that an alternate pipeline was planning an expansion, right? And we could go and secure firm gas transportation for this site by working with them. And so we have now marched down the path where we have secured firm gas supply from them through an alternative pipeline provider. We will be bringing the gas to the facility, and this project is going to have an online date that's far sooner than what the grid can provide, right? And so this is a specific example where, we were able to solve a very critical gas supply issue for them. And without having solved that issue, this solution wouldn't have worked. Like, we couldn't have gotten an on-site power generation project going. So that's a very specific example. Another example was a data center that wanted to be inside a non-attainment area. Air permitting is a really critical piece of this. We have to think about ozone. We have to think about NOx. They wanted to be in a non-attainment area. They weren't going to be able to get the power. So the question is, could we design a hybrid solution where they're going to get some power from the utility, some power from an on-site source, which, because it's in non-attainment, has to be maybe a little bit smaller than we would want outside of non-attainment. But now the question is, can we deliver power inside one data hall, data building, meaning one building that has multiple sources, meaning that one building, not one, has some halls that are powered by natural gas behind the meter, some halls that are taking grid power, everything that needs to be connected to their backup systems, right? Their backup diesel generators. So how do you solve for that? And what does the electrical distribution strategy look like? And how do you ensure redundancy? That's another example where we solve that problem and, are continuing to progress that project. So, I think for us, we can be as high level and solve problems at the 30,000 foot level. We can be in the very nitty gritty, but really we want to be a partner to the data center. Like, we want to collaborate, solve the problems together, roll up our sleeves, and, put our money and capital where our mouth is, for lack of a better term.
So what are the bottlenecks when connecting a data center to this network?
Okay, so, there is a very extensive natural gas infrastructure. We're blessed to have a lot of gas supply, and then we're blessed to have thousands of miles of, pipeline networks. Now, the devil is always in the details, right? Because these pipelines were already built to serve specific markets, specific customers. And so while they're a lot less congested than the power grid, there's still pockets where it's constrained and you're not going to be able to get gas where you need it to go. And I always separate like the supply, meaning what producers are doing from a drilling and production perspective, and transportation, which is, can you get the gas where you need it, when you need it? And that's a constraint that's really very local. You have to understand what the local grid dynamics are in a specific region to be able to understand where you have available capacity that you can access today and where there are expansions coming that are maybe going to be a little bit faster than what the grid can do and what you can access. So I would say that's the biggest thing to think about, is if you're going to site projects from a gas perspective versus a grid perspective, you have a lot more options. That said, you still have to know where there are, available pockets of capacity, right?
So you talked a little bit about the flexibility. I heard you say that word, of the natural gas industry compared to utilities. Can you provide an example of how this flexibility benefits data center operators?
Yeah, I think one thing I'll say is data centers are used to a fast pace, right? Data centers are used to responding to tenants very quickly, bringing capital, moving enormous amounts of resources to be able to, deploy compute, right? Unfortunately, the utility timeline and the data center timeline are in direct conflict with each other. That's why we're here. That's why we're talking about this. The natural gas market as a whole has a little bit less complexity, a little bit more regulatory flexibility than anything you can get from a utility, right? Because the pipeline network is very, very extensive, a lot more sites and locations are going to open up for data centers, right? So a market like, I'm going to say, Phoenix, right, which may be grid constrained, there are places in that market where gas is available and you can site a data center. So for one thing, it's going to open up more locations for you. The second is the gas market in general, they're faster and will respond more quickly versus the utility. The utility is managing the PUC, the regional transmission organization, the investor-owned utility. They get a rate of return whether they serve a data center or a residential customer, right? So they have no economic incentive necessarily to move faster for you because their rate of return is fixed. They're not getting paid to move faster for you necessarily. Not that they don't want to, by the way. It's just the incentive structure is structured differently and they have a lot of hurdles to walk through. The pipeline operators and the gas suppliers, they'll respond to economic incentives. So if they see demand, they'll respond. And so I think that flexibility is available to the data center by opening up more regions for development and being able to access power faster. The third thing I'll say, and this is really about kind of the natural gas markets and the ability to structure products and manage price and volume risk, you have a lot of ability to access that through the gas markets. They're very liquid, they're very diverse, there's a lot of players, you get a lot of flexibility. So there's that piece of it too.
Let's go a little bit deeper into air permitting.
Okay.
Because you had said it's really a significant factor. How does GPC approach site selection and project design to navigate these regulatory requirements?
Okay, so air permitting is a big one. Okay. non-attainment for ozone and NOx, severe non-attainment, maintenance non-attainment, all these are different statuses. No, that's not maybe a word, but
I think it is. It's a word.
we'll say it is. So counties will, have a status for their air quality, right? And that will restrict to what extent you can develop there. So I'll give you a really good example. The DFW area we know is a tier 1 data center market, but the 9 counties that are surrounding DFW are all in severe non-attainment for ozone. That means if you want to develop inside that area, you're going to need to access either emissions offsets where someone else has shut down their operations and have effectively freed up capacity for you to develop there, or you're going to have to limit the size where you're developing to be able to get a permit, or you're going to need to move outside of those areas to avoid these restrictions. And so for us, air permitting, understanding what the restrictions are, knowing where we can site, knowing where the air modeling requirements will allow us to develop, and then finally designing and putting the right equipment in place to be able to meet those standards, all of that is part of that value proposition and what we think about and how we think about it from the very beginning. I mean, frankly, I'll tell you, we're not land developers, but we will work with land developers to identify sites where we can deploy solutions. And sometimes that's part of the value we bring, which is you want to develop here. Well, if you move, 20 miles here, we have a site we can offer to you. You can connect directly with the land developer, but we've vetted it from a gas perspective, from an air perspective. And we think permitting here is going to be a lot easier than if you try to permit here. So I think that comes into, how we look at locations and how we assess their limitations and what we can do. I mean, the other thing data centers talk a lot about is we want to get to a gigawatt deployment. Well, that's a huge impact, right? And so planning for that ahead of time, I don't want to just be at a place where I can maybe get a 50 or 200 megawatt permit now. If I have a plan to be at 1,000 megawatts, I can't get there from a permitting strategy perspective, probably better to look elsewhere. So those are just some things to think about.
Let's just take a broader view of the industry and talk about hyperscalers. Yeah. And that's all we hear about these days in the data center world. But obviously, hyperscalers are building increasingly large data centers to accommodate the explosion of AI. How does GPC's on-site power generation solution scale to meet these demands?
Well, I mean, the beauty of a lot of the equipment that we're talking about is it's containerized, it's modular, and it can scale. So we don't have to deploy 1,000 megawatts today. We need to think about the design for that today. We need to think about, do we have gas supply that can accommodate that? And if the expansion is happening, we probably want to get ahead of it and secure that today. But from a equipment perspective and a staging equipment perspective, once we've kind of thought about the gas supply and the permitting for the full range of the project, staging in additional equipment over time is kind of part of our process, and it's part of how the equipment providers are thinking about it too. So we really think about it from a modular perspective and the ability to add, capacity over time.
So data centers are evolving to have more in common with, I guess, large industrial complexes, right, that historically have had significant on-site generation. What does this mean for the future of data center power infrastructure?
Okay, I'm probably going to get pilloried for saying this. I know I am. And
good. Bring it on. Let's do it.
I'm going to put it out there. I'm going to be controversial. And I will say that I think that the data centers of tomorrow are going to have more in common with a refiner or a chemical manufacturer or a pulp and paper mill than you would have ever thought, 5 or 10 years ago when you're driving down a highway and you see a data center. And that's because large industrial loads, very, very large industrial loads that have had high power needs have traditionally had a model where they self-generate some portion of that power. A lot of times they co-generate, meaning they capture the waste heat and use it either to support an industrial process or to have a combined cycle generation or to just be a very, very efficient generator, right? And then they have a part where they interact with the grid, where that generator either places the excess power and sells it back to the grid, or they may have a load that's taking some portion of power from the grid. But it's a hybrid approach. And They do this to be able to control their own destiny to a certain extent. They also do this to optimize around price and risk and from a redundancy perspective. And they do this to be highly efficient. And when you're talking about data centers that used to be maybe 10 or 20 megawatts and now are going to be more like 500, 600, or to a gigawatt, this is the model, I think, that has been well tread, right? Other industries have done this, have solved for this. I understand that maybe the end use case and the end reliability needs may be slightly different, but at a 30,000 foot level, you are a highly concentrated load. You're a very large load. And this is, I think, where the data center industry will find itself, to kind of go down this path where you take some ownership and have self-generation as part of the solution set, right? I think it makes a lot of sense. And it's a responsible way to handle this development, which interacts responsibly with the grid and with the ratepayers, right? Rather than asking the ratepayer to be responsible for all of this incremental load, it's a partnership and a win-win for both.
Everything you're saying just makes so much sense. And I know I told you this last week. It just seems like, what are the challenges with adoption? A broader adoption, and what do you foresee running into when you're really trying to help data centers take this on?
I think anytime you're introducing, even though this is a solution that's established in other industries, it's still new to the data center space, right? So for a long time, the question was, would this even hunt? Would there be any acceptance that on-site natural gas specifically could be a part of the solution? I think that paradigm shift is starting to happen, and that pivot of, hey, there's a real need here and we can go deploy these projects, I think that's happening. But I think to fully scale the solution, we have to earn the trust of the industry, and we have to provide the reliability that the industry is looking for, and we have to prove it, right? Like, that's where the rubber will meet the road. And I always say, like, trust and reliability are the cornerstones of how we win as a solution and how GPC wins specifically. And I think that's where we are today, is we find the right level of kind of risk sharing, right? Because here it's a partnership. We're coming on site. We're a permanent solution for the most part. Our role can over time transition to backup if needed when the grid is available. But we are on site as a kind of permanent installation, if you will. And so as part of that, we have to design for that 5 nines of rack level reliability. We have to always be there. We have to meet the uptime needs of this industry and the ramp up, ramp down, and transient needs of this industry, and be able to solve for that. I think that's what we need to, that's kind of the Rubicon we need to cross. That's the valley we're walking through right now. And that's what we're trying to prove ourselves as partners and problem solvers.
So, Gauri, I'm curious about this. Like, what is it that drives you? I mean, you are so passionate. I love talking to you. Your energy just lights me up. And obviously, you and your team have an enormous amount of experience and knowledge in this area. So I have no doubt you're going to accomplish your goals. But what drives you? What is your why? What do you see so exciting about the future?
Okay, so I will give you 2 answers to that question. Okay. My personal why is I love solving problems, and I love building a team, and I love just being in the thick of seeing what the challenges are and seeing if we can solve those and meet those challenges, right? And do it in a responsible way. Do it in a way that's a win-win for everybody. Like, maybe that's a little Pollyannish of me, if you will, but just the notion of, hey, here's a big problem. Here's a big problem for this industry. Here's a big problem for, the progress of technology and really for our society, right? And how do we do this in a responsible way? And can I bring something personally to the table that moves the needle? And can I do it in a way that is with people I love being around and developing long-term relationships and really being a problem solver and bringing value to the table? So my personal why is I just love the challenge of it. I love knowing and seeing if we can try to make a difference here, right? So that's my personal why, I guess. I think the other answer I would give you is maybe, I'm a parent. I've got 2 kids, 11 and 7. And, I think our world is really, really rapidly changing. And I think that showing them, like, laying the groundwork for something that's kind of bigger and being part of it and saying, hey, look, you can do big things too. And there's big problems that can be solved. And don't let a lot of kind of the volatility and all the things that we're dealing with, don't let that get you down. Like always, keep fighting, always keep going, and, don't give up. Like, I think for me, that's really important in how I try to live my life and what I try to show my kids. So I don't know. I don't know if those are good answers.
I love it. It just reminds me, I have this behind me, behind my desk, trust your crazy ideas. And yes. I completely agree with you about the kids. I mean, I have a similar view with my children, and, my kids really believe, at age 24 and 26 that anything is possible. Like they can create anything. So more power to you. Gauri, you are such an inspiration. Oh my gosh. You just thank you. Thank you for coming on the show. I know you've inspired so many people today. How can we reach you? How can we learn more? Your website, maybe, yes. I don't know, phone numbers?
Yes, all of these are available. Please go to our website, www.gpcinfrastructure.com. It stands for Gas Powered Compute. If you want to tell yourself it stands for Gauri Potdar's company, you can also do that. It doesn't stand for Gauri Potdar's company. It stands for Gas Powered Compute, but gpcinfrastructure.com. We'd love to talk to anybody that has potential sites, is thinking about whether they can bring gas to a site and is looking for a partner. We'd love to talk to other providers that are in this space to compare notes, to see how we can collaborate and push through and share ideas. And we just are very excited to be part of this industry and try to help.
I'm so excited to meet you. I can't wait to see you at the next event. Gauri, thank you so much for coming on the show.
Thank you very much. Really appreciate it.
Take care.
Take care. Bye-bye.
Thanks for tuning in to Let's Get Digital. This podcast is powered by Broadstaff, a national staffing firm specializing in digital infrastructure talent. Don't forget to subscribe, leave a review, and join me next time as we explore more stories at the intersection of technology, talent, and transformation. Until then, let's get digital.